Hello, this is Tim Smith, the Academic Support Coordinator for St. John's River State College, St. Augustine campus. This video, Properties of Functions, is designed as a study aid and supplement to the math tutoring services offered at St. John's River State College. In this video, we will be discussing even and odd functions, increasing and decreasing functions, local maximum, local minimum, absolute maximum and absolute minimum, and the average rate of change of a function. A function f is even if for every number x in its domain, the number negative x is also in the domain, and f of negative x equals f of x. A function f is odd if for every number x in its domain, the number negative x is also in its domain, and f of negative x equals negative f of x. A function is even if and only if its graph is symmetric with respect to the y-axis. A function is odd if and only if its graph is symmetric with respect to the origin. An even function is where f of negative x is equal to f of x. Let's look at the simplest example of an even function. We have previously learned the graph of f of x is equal to x squared. In this case, the squared function turns a negative into a positive, as in the example f of 2 equals 4, and f of negative 2 also equals 4. Therefore, f of negative 2 equals f of 2. This is true for all x, therefore this function is even. Also notice that the graph is symmetrical about the y-axis. An odd function is one where g of negative x is equal to negative g of x. Again, using the simplest example, g of x is equal to x cubed. The cubed function retains its sign, as in g of 1 equals 1, and g of negative 1 equals negative 1. This fits the definition of the odd function because g of negative 1 is equal to negative g of 1. This is true for all x's, therefore this function is odd. Note that this function is symmetric across the origin. For another example, let's determine whether the following functions are even or odd. First, f of x is equal to negative x cubed minus 27x. Since this function begins with x cubed, we suspect it is an odd function. If so, then f of negative x equals negative f of x. F of negative x equals minus negative x cubed minus 27 times negative x. We simplify to get x cubed plus 27x. Negative f of x is simply minus the quantity of negative x cubed minus 27x. Simplify to get x cubed plus 27x. Since these two are identical, this function is odd. Next, we try g of x equals negative x to the fourth plus 32x squared plus 144. Since the highest power is an even number 4, we will test this function for being even. If so, then g of negative x is equal to g of x. G of negative x equals minus negative x to the fourth plus 32 times negative x squared plus 144. Negative x to the fourth equals x to the fourth, and negative x squared equals x squared, leaving us negative x to the fourth plus 32x squared plus 144, which is equal to g of x, so this function is even. A function f is increasing on an interval L if, for any choice of x1 and x2 in L, with x1 less than x2, we have f of x1 is less than f of x2. On the graph, this is read as x increases from left to right, y will also increase. A function f is decreasing on an interval L if, for any choice of x1 and x2 in L, with x1 less than x2, we have f of x1 is greater than f of x2. On the graph, this is read as x increases moving left to right, y will decrease. A function f is constant on an interval L if, for all choices of x in L, the values of f of x are equal. On the graph, this is read as x increases from left to right, y remains the same. For this example, we'll use the graph of the function f to the right. On the interval -3, -2, Is the graph increasing, decreasing, or constant? From -3 to -2, the graph is going down, so it is decreasing. On the interval -1, 0, is the graph increasing, decreasing, or constant? On the graph between -1 and 0, the graph is going up or increasing. On the interval 1, 2, is the graph increasing, decreasing, or constant? Between 1 and 2, the graph depicts a horizontal line. Therefore, on this interval, it is constant. Let f be a function defined on some interval L. A function f has a local maximum at C if there is an open interval in L containing C, so that for all x in this open interval, we have f of x is less than or equal to f of c. We call f of c a local maximum value of f. A function f has a local minimum at C if there is an open interval in L containing C, so that for all x in this open interval, we have f of x is greater than or equal to f of c. We call f of c a local minimum value of f. Let f be a function on some interval L. If there is a number u in L for which f of x is less than or equal to f of u, then f has an absolute maximum at u, and the number f of u is the absolute maximum value of f at L. This graph depicts an absolute maximum. If there is a number v in L for which f of x is greater than or equal to f of v, then f has an absolute minimum at v, and the number f of v is the absolute minimum value of f at L. This graph depicts an absolute minimum. If a and b, with a not equal to b, are in the domain of a function y equals f of x, the average rate of change of f from a to b is defined as the change in y over the change in x, or f of b minus f of a over b minus a for a not equal to b. The average rate of change of a function from a to b equals the slope of the secant line containing the 2 points a f of a and b f of b on its graph. Finally, let's fully evaluate the following function. F of x is equal to negative x squared minus 2x. First, we look for whether this function is even or odd. F of negative x is equal to minus negative x squared minus 2 times negative x. We simplify to get negative x squared plus 2x, which is neither f of x nor negative f of x, so this function is neither even nor odd. To determine the next set of properties, let's graph the function. By setting the function equal to 0, we can get the x-intercepts. Negative x squared minus 2x factors to get x times the quantity of negative x minus 2. Therefore, x equals 0 and negative 2. This gives us the 2 points, 0, 0, and negative 2, 0. Since this is a quadratic function, the vertex can be determined by taking negative b over 2a and f of negative b over 2a. Taking negative b over 2a gives us 2 over negative 2, or negative 1. F of negative 1 is 1. So the vertex is negative 1, 1. The highest exponent is the negative x squared, meaning this is a parabola opening down with a vertex of negative 1, 1, with points 0, 0, and negative 2, 0. With the graph depicted, we can see that the function increases on the interval negative infinity to negative 1, decreases on the interval negative 1 to infinity, and has an absolute maximum that exists at negative 1, 1. Next, let's find the average rate of change on the interval negative 1 to 1. We start with the rate of change equation and fill in for the interval negative 1 to 1, or f of negative 1 minus f of 1 over negative 1 minus 1. F of negative 1 is 1. F of 1 is negative 3 over negative 1 minus 1. Simplified to get 4 over negative 2, or negative 2. So the rate of change from negative 1 to 1 is negative 2. Negative 2 is also the slope of the secant line. If you have further questions on this or any other math topic, or wish in-person tutoring, please consult the academic support coordinator on your respective campus. Thank you, and good luck with your studies.